This is what peristalsis actually looks like on a systems level. We're not going to walk through the entire diagram today, and what you're seeing on the screen is my iPad, or if they're connected. I want you to see it first because when most people think about digesting food, they're thinking of a single muscle that's pushing food through, but it's a coordinated signaling process. Now, understanding this matters deeply when we're talking about gut motility disorders, because one of the biggest problems with how conditions like gastroparesis are explained is that they're incredibly oversimplified. Now, people are told that their stomach is slow or it's not contracting properly without ever really being shown why that's happening. And when you don't know what's happening or you don't understand what's happening with the system, it's almost impossible to understand how you're actually going to help it. So what I'm doing here is I'm intentionally building foundation so that it makes sense, but so that also when we go back to talk about supporting the motility, you actually know what you're supporting. Now you're going to follow along with me on my iPad, but peristalsis does not begin with a single muscle contraction. It actually begins electrically. Now, along the gastrointestinal tract, inside here, we have pacemaker cells. And those pacemaker cells generate what's called a slow wave. So we'll come down here to the slow wave. And the slow wave is a rhythmic change in electrical potential. Now, this slow wave that you're seeing here in purple and now green, it sets the timing of digestion, and on its own it doesn't move through. But what it does do is create the window in which movement can happen. Now, when that electrical signal reaches threshold, now here you're seeing threshold here. That's not so pretty. It reaches, its spike activity occurs. So you're seeing the spike activity. Now, calcium ions enter smooth muscle cells and contraction follows. So you're getting the calcium channels here. They're going to come all the way up here and they're going to be spiking. Now, I want you to focus on this section here specifically. You'll notice that these slow waves, they're always present whether food is moving or not. But effective peristalsis, it happens when the electrical rhythm is properly coordinated with spike activity. Coming back up to the food, the bolus, which is the food. So behind this is circular muscles that are supposed to be contracting. In front of the bolus, those muscles are supposed to be relaxing. That relaxation is just as important as the contraction, and it requires precise inhibitory and excitatory signaling. Now, when that coordination breaks down, which is very common in gastroparesis and other motility disorders, movement becomes inefficient or delayed or incomplete. And this is where symptoms kind of start to make sense. When timing is off, pressure builds. Now, the system hesitates. Movement becomes irregular. And the nervous system, it starts to perceive the peristalsis. So now you're feeling it physically. That's why people with gastroparesis, they'll be like, why can I feel the inside of my stomach moving? Not because they're anxious, not because they are focusing too much, but because the system has lost coordination and the signals are no longer quiet. Okay, so this is also why generic advice like just relax or reduce stress isn't often enough. Relaxation can lower background noise, and that can help, yes, but it doesn't correct electrical timing. It doesn't restore signal thresholds, and it does not resolve coordination between layers of muscles and nerve signaling. So if we want to meaningfully support gut motility, we have to understand this, like how the system is actually failing. And this is the first step in a larger educational process. I'm going to be walking through how gut motility actually works slowly, cleanly, accurately, so that when we talk about supporting it, we're doing so with real understanding instead of guesswork. And I think that all of us with these kind of conditions are really done with guesswork. In the next video, I'm going to go into what controls this timing, including calcium ions, threshold, and frequency, and why those details matter so much in conditions like gastroparesis.